Good morning, everyone. We're going to try to start right on time. For those who are standing on the back, there are a few chairs in the front row. If you want to take them, there are at least 7 or 8 chairs. Okay, so good morning. Thank you, everyone, for coming. I want to start right on time because we have an outstanding set of speakers, and I want to have time for all of them to talk. Please come to the front row. There are seats here. Thank you. Okay, so this symposium is about estimands. So ready or not, they are here. So let's see what we can learn about estimands in this session. I want to say a couple of words for each to introduce our panels. I'll go first because I'm first in the slide, and I'll follow the order in the slide. I'm Xavier García de Albeniz, epidemiologist in RTI Health Solutions. We also have Costel Chirila, who's Director of Biostatistics, also in RTI Health Solutions. Then we have Professor Miguel Hernan, who's a colloquial honors professor in biostatistics and epidemiology at the Harvard School of Public Health and director of the Causal Lab. We also have Paul Klutz, who's a medical oncologist and deputy director of the Oncology Center of Excellence at the US FDA. Daniel Morales, who's a general practitioner and epidemiologist at the University of Dundee and current member of the European Medicines Agency Pharmacovigilance Risk Assessment Committee. And Jason Roy, Professor Roy, he's a professor of biostatistics and chair of the Department of Biostatistics and Epidemiology at Rutgers University. So you can see we have an outstanding panel of speakers today. So thank you to them. So the motivation for this symposium is that the estimand framework was introduced in 2019 by the ICH to describe causal estimands beyond the intention to treat effects in randomized trials. And then the target trial emulation framework also starts by specifying the causal estimands in a target trial. This framework, as you know, has helped reconcile results of randomized trial and observational studies. But there are some differences on how these causal estimands are being discussed. So this is what we were going to try to explain and discuss, and we hope that we have a lot of discussion and interaction with the audience, of course. So I won't go over the objectives because I'm sure you read them if you're here. Each speaker will speak for about 15 minutes, and then at the end we will hopefully have about 25 minutes for discussion and for questions from the audience. So without further ado, Daniel, let's get the slides.
Thank you very much. It's great to see so many people here. Just to clarify, I left Prague recently. I'm now part of the Data Analytics Task Force. And I'm going to give you a regulatory perspective about estimands. This is my disclaimer slide. So if we start at its most basic, regulators need to understand the effect of treatment on a health outcome, as do other stakeholders. And as part of EPI 101, we have it drilled into us to always define the research question. The reason for that is to inform the study design choices. But there are multiple potential treatment effects that could be considered to answer that research question. Some of these are going to be more relevant from a regulatory decision making than others. If we give an example, is that, you can't hear, no? Okay. If we give an example, if we want to conduct a real world evidence study, a new user active comparator cohort study, we could do one analysis where we include all new users, and we can do another analysis where we exclude people with the outcome event of interest prior to drug initiation, perhaps over concerns over the validity of the outcome measure. What we're actually doing is slightly changing the estimand, particularly in terms of the population attribute. And in many instances, the relevance of that may not make a difference to the research question, but in others it may do. And problems can arise from a regulatory perspective when the treatment effect isn't defined and specified in advance, in case you answer the wrong estimand. And this is particularly a problem for clinical trials if data collection is part of that. So estimands have been around for some time, and I think the ICH E9 guideline addendum really brought things to the forefront. And it's a way of being explicit in the research question, the estimand, and also the design choices that are being made. And it applies the estimand framework. The estimand framework focuses on describing the estimand's attributes, the intercurrent events and strategies for dealing with those intercurrent events during follow-up, and also the effect measure. And whilst it's principally applied in terms of confirmatory clinical trials, it does state that the estimands are relevant to all studies in which a treatment effect is estimated. And there are also special regulatory considerations when we consider equivalence or non-inferiority trials, where the analysis has to be more or less conservative depending on the relevance. So if we take an example of how the estimand framework maybe features in one of the guidelines, here's an EMA guideline of medicinal products for the treatment of prevention of diabetes. Now we know that glycosylated hemoglobin, or HbA1c, reduction lowers complications in people with diabetes. And the guideline recommends a primary treatment target, which is the difference in HbA1c from baseline to the end of the trial. Now, there are a number of intercurrent events that it discusses, and two common ones here. One is treatment discontinuation, where it recommends and discusses a treatment policy strategy, which corresponds to an ITT approach. And the other would be the use of additional or rescue medication, where it discusses the use of a hypothetical strategy, and this is where we assume that any additional or rescue medication doesn't have a major effect on HbA1c. Now, in terms of these guidelines, the ICH guideline implementation within EMA is undergoing an implementation phase, aiming to be fully implemented in early 2025. And other guidelines are being reviewed, such as the Methodological Working Party is reviewing the guideline for the statistics applied for non-inferiority trials. So how were estimands referred to before ICH was published? In terms of the description of estimands and its potential attributes among EMA guidelines, sponsor documents, or regulatory questions. And Mitre et al. Did a review of a sample of documents from 2017 and earlier within the EMA system. They found that all of the attributes that we see in the ICH guidelines, and these were applied retrospectively to the test descriptions, because obviously the guideline wasn't present at that time, were specified in only 12% of the EMA guidelines from that sample, in all of the sponsor documents, and 3% of the regulatory questions. The information on the attributes, though, were difficult to find and scattered in many different sections. And the attribute that was least frequently described was that related to the population. In terms, and also an ITT analysis was the most advised, was advised by most guidelines, and that corresponds to the treatment policy strategy. Intercurrent events were described in 8% of guidelines, all of the sponsor documents, and 68% of the regulatory questions, with strategies to deal with those intercurrent events found in a slightly less proportion from a regulatory perspective. The most likely strategy for dealing with an intercurrent event in the sponsors proposals was the hypothetical strategy, and the regulators typically recommended a combined hypothetical and a treatment policy strategy. Interestingly, in terms of when ITT was proposed, often the population deviated from the definition of the ITT principle. We could see some examples of this on the right. We could take a clinical trial, this applies to clinical trials, take a clinical trial where the proposed analysis will involve all randomized patients with at least one follow-up measurement available, whilst another will propose all randomized patients with baseline measurement available, at least one post-baseline measurement available, and having took at least one of the study drug. So as you can see, all are intending to answer the same research question, but the attributes of the treatment effect that's being measured is slightly different potentially. So what's changed since the ICH guideline has come about? And recently there was a review of requests for scientific advice at the EMA from 2022. And this figure shows, focusing on clinical trials, the number of clinical trials where sponsors were proposing to use the estimand framework. We can see that most of the clinical trials were phase 3 clinical trials, and just under half of them proposed to use the estimand framework, with smaller numbers of trials for phase 2 and phase 1. Of sponsors that didn't propose to use the estimand framework, what proportion did the EMA or CHMP recommend the estimand framework? And we can see here that among the phase 3 trials, it was recommended in 61%, both of the phase 2 trials and none of the phase 1 trials. And overall, the estimand framework was either used by the applicants or recommended by CHMP in around 80% of the phase 3 trials. In terms of intercurrent events, the most common type of intercurrent event that was mentioned was that focusing on treatment and treatment discontinuation. And here we see a figure on the left. It's the proposed strategies. It's the strategies proposed by the applicant, and on the right is the recommendations proposed by the regulators. Whilst historically before the ICH guideline was published, applicants typically propose a hypothetical strategy. Here it was either the hypothetical or the treatment policy strategy, whilst the regulators still were more likely to propose a co-primary or combined strategy of both of those. So I'm now going to move on to the statement in the guideline that says these principles are applicable to all types of studies. So how applicable are they to real-world evidence? I think in many instances, many of these things do align. So there should be an agreed estimand, yes. The statistical analysis should be aligned to that estimand, yes. Estimand should be defined and explicitly specified in protocol, ideally, and I think there's room for that. And I would like to see, our studies really being explicit of whether we're evaluating an average treatment effect or an average treatment effect in a treated, whether it's a mediated or conditional effect. Clarifying the estimand in the estimation methods, would that help to plan which data are needed? Probably yes. And sensitivity analysis should focus on deviations and assumptions for estimand analysis. But there are a number, in terms of real-world data, there are a number of other approaches that are potentially very suitable for the evaluation of intercurrent events, which we would typically consider more from the causal inference field. And indeed, this year, EMA has published a draft reflection paper on the use of real-world data to generate real-world evidence in non-interventional studies. And they recommend the estimand framework may be integrated into the design of a hypothetical target trial and its statistical analysis. But one of the aims here is to increase the coherence between the definitions of things used in clinical trials and non-interventional studies, which then raises a question that we're potentially dealing with two different languages. One of the languages regulators are currently more familiar with than the others, and how we might address that. I think one other area in terms of just to potentially raise is that we know that real-world evidence can be used to support regulatory decision-making in 3 broad areas. One of those is to support and planning and validity of applicant studies, to understand the clinical context, and to investigate associations and the impact of regulatory interventions. And given the importance of intercurrent events for both the target trial emulation framework and the estimand framework, then probably real-world data has an opportunity to really go in depth in studying these different types of intercurrent events. And that should have some benefits to both. So in terms of discussion points or personal reflections, I think stakeholders need to understand what has been estimated to make informed decisions about evidence, and what might be suitable for a regulator, maybe different to what a patient group or someone else wants to see. So can we be clear about what is estimated, and importantly, what it actually means? If study designs or methods of analysis can be improved with target trial emulation and estimand frameworks, how can they complement each other, and what language do we use? And what would be the implications for feasibility assessments, protocols, or even reporting guidelines? And going full circle back to EP 101, I suppose ask not what question you can answer with your data, but what data you need to answer your research question, and now estimand. Thank you.
Thank you very much. Now we'll have Professor Roy.
Figure out how to full screen it. What do you think about full screen? Oh, I can just do this. Okay, this will be fine. All right. Yeah, so my role here is to really... Okay, go. This one? Thank you. Okay, yeah, thank you. Okay, so yeah, I'm going to present the ICH framework, this addendum, as well as I can. I wasn't part of the council that came up with these guidelines, but I think I'll try to do as fair a job as I can of sort of summarizing in 15 minutes what it is. And just as a sort of background, which hopefully, and you got some of that background just now, but just to give a little bit about it, we have this ICH that has this mission about achieving this greater regulatory harmonization worldwide. So it's this consensus-driven approach, and it resulted in, one of the things it resulted in is some guidelines. And as was mentioned, we have these E9 guidelines that really focused on intention to treat. And I think there's a lot of really nice stuff in there as far as just basic principles of intention to treat, where, for example, if there's non-compliance, you don't delete the people who didn't comply. The standard intention to treat things that, principles that prevent you from going astray and having bias and losing the randomization. But then there was this addendum, as was mentioned, that now focuses on estimands and sensitivity analyses, and really in a large part driven by the issues surrounding intercurrent events. So I'll focus on this addendum. And I'm taking some slides directly from the documentation. So there's an addendum document, but there's also slides that sort of summarize. And I'm taking a few slides from there so I can be completely fair to what they said. And this is a summary of the addendum. And so one of the things that's, that there's a lot of focus on estimands, which, as they're describing as what is to be estimated. So what is it we want to know? And they're saying that, that's obviously a really critical question to think about ahead of time. What is it that we want to know, and to make sure sort of everything then in our study is aligned. So that's what this is talking about here, is that we figure out what we want to know, the estimand, and then making sure everything's sort of aligned with that the study design is appropriate for that, and that ultimately you end up with then having proper interpretations and so on. And so this is sort of the big picture of what they're kind of thinking about, is sort of up front thinking about this trial objective and having the estimand match this objective. And then once you sort of know that, you could be thinking about your estimator, and then ultimately having an estimate. But they also talk about doing sensitivity analyses as well. So this is sort of the kind of big picture around that. And so there's, just to reinforce this, they want this alignment between the objectives design and conduct and analysis of the study. But a lot of this, again, is driven by these intercurrent events. So I'm going to spend a little bit of time talking about what they mean by intercurrent events and how that relates to estimands, and so on. So that's a lot of what I'll talk about. So this is what they described as intercurrent events. Events occurring after treatment initiation. Okay, so it has to occur after treatment. That affects either the interpretation of or the existence of measurements associated with the clinical question of interest. So I'll cover both cases where they mention interpretation of and also existence of. So I'll cover both cases so it's clear what they're referring to. So here's the interpretation of, and this one was also mentioned just a few moments ago with this diabetes example. But you could imagine in general, let's say there's two different treatments, two different medications, whatever it is. I'll call it treatment A versus treatment B. There's an outcome Y, and then there's something that could happen in between, such as use of additional medication, maybe use of rescue medication. And the concern is that with an intention to treat approach, it could be maybe treatment A isn't that good, so people stop using treatment A right away, but they then take other things that make their outcome look about as good as treatment B, right? So that's one example, is you could see this sort of, because the medication doesn't work, or maybe there's side effects, they stop, but then they take other things, and then their outcome looks maybe just as good. So if you just looked at intention to treat just on this outcome, maybe you sort of miss this bigger picture of what's happening. And they proposed a few different types of estimands you might want to be interested, that you might be interested in this kind of a situation. And I'll use some potential outcome notation here. So little a here is like a treatment, but it's really a treatment assignment here. So it's really kind of randomization. So if you're assigned to one treatment versus the other. So what I'm calling intention to treat here is really this average difference in the outcome if everyone was assigned one treatment versus if everyone was assigned the other. And I just mean assigned, not what people actually did. So that's this intention to treat estimate. But they also mentioned, well, once you think about these intercurrent events, maybe we want to take into account the sort of subsequent medication use. And so I'll call that I for the intercurrent event. So little I is, we're imagining, what if we could say, oh, this rescue medication isn't available. So that's what they said in this document. So now we have an estimand that's comparing what if everyone's treated versus what if no one's treated, or what if everyone's treated with treatment A versus what if everyone's treated with treatment B, but for nobody was this rescue medication available. So that's one possible estimand you could consider. And then another one that they mentioned a few times are these principal stratification type of estimands, and that's what this last one is here. So I'm also using additional potential outcome notation with the intercurrent events. So if I have capital I with a 1, that means that the intercurrent event, it's the intercurrent event sort of under, if you randomize to, let's say, treatment A, versus what the intercurrent event would be if you are randomized to treatment B. And what this one is saying is, well, what if we look at only consider the subpopulation of people that would never use additional medication or rescue medication under either treatment. So there's a subgroup of people that aren't going to take this additional medication under either treatment. Now let's make inference about that population. So that's another one that they talked about. So there's this question of which one of these do you want to know? But there's also, in my view, which I'll talk about later a little more, is there's a question of which of these are identifiable from, might be identifiable from your data, or more realistically identifiable. So we sort of will need to think about both factors. What do you want to know? What's useful to regulators? And also what's identifiable? So I kind of mentioned that here. And I mentioned a little bit about each of these estimators. So ITT, intention to treat framework, it's pretty clear that probably just this one outcome isn't quite enough. Maybe you could consider the use of rescue medication as another outcome and sort of think of those jointly. That would be one possibility. The estimand that sets rescue medication to 0 for the whole population, you have to, again, I think the main issue there is, well, is it the kind of thing that we really want to know, but also would it be identifiable from data? And so I think that's, to me, would be the biggest issue there on whether that would actually be identifiable. And then this principal stratification approach, I think there's a question on how useful it would be to regulators, given that this subpopulation of people are not a priori identifiable. So you wouldn't really, know, if a patient walks in the door, which principal strata they're in, and then whether we have evidence for this working or not for them. So that's a question that I'll just leave open. Okay, then the other type of intercurrent event they mention are events that happen after treatment that affects the existence of measurements. So this is quite a different type of thing. And so what we're really thinking about here, one common example of this would be something like you have some kind of biomarker, or in this case, let's say you're looking at quality of life or body weight or something like that. But then you have patients who are dying maybe before this could be measured. Let's say you want this at 12 weeks. Some people die before 12 weeks. That's the intercurrent event, is that they died. Now we don't have this outcome measure, right? And so it's it's pretty clear that there's a lot of naive things you can do that would probably be bad, like just removing people who died from your analysis or something like that, or imputing weight after they died. So things like that. So I think they've identified, you know, an important problem to think about. And then again, you could think about what estimands would you want to know in this kind of situation. One of them, and you know, you could, I think this sort of average treatment effect probably isn't very meaningful, because that's sort of thinking about what's everyone's quality of life at 12 weeks, even if you know, but given that some people died, maybe this isn't super useful or identifiable. An alternative one, again, you could kind of think about a principal stratification approach. Here we're talking about the subset of people who would be alive at 12 weeks under either treatment. Now we can look at their quality of life or their weight. And so again, it's a question of, is that sort of meaningful to regulators, given that we won't know who these individuals are ahead of time, so there's this latent subpopulation. So here's more examples that I took from one of their slides in terms of intercurrent events. So you can see there's some of the ones they're thinking about are discontinuation of treatment. They're thinking about uses of additional treatment, treatment switching, and then, you know, for the terminal events, the kind that stop the thing from being measured, they have leg amputation and death as examples. And so the addendum is pretty long with a lot of information, so summarizing in 15 minutes is a little difficult. So I just wanted to have one that just highlights a bunch of other things they covered to make sure I'm being fair to this document. And so there's a lot of things they talk about, including the need to be precise when you're talking about intercurrent events. That intercurrent events they're not necessarily the same thing as missing data. Estimands, they need to be clinically relevant. You could consider composite strategies, incorporating ICs into the outcome. You know, the choice of strategies, you know, should be the object of multidisciplinary discussion between sponsors and regulators and so on. And the description of preferred strategy for handling each intercurrent event should be precisely defined in the study protocol, and so on. And then I'll have just a couple quick sort of summary points. So in my view, these are things I personally think are not controversial. We'll see if other people agree, but I think these are pretty safe. So intention to treat alone might not be sufficient to understand treatment effects. What they call intercurrent events can be important when it comes to thinking about estimands of interest. Estimands should be clearly defined, match the trial objective, be clinically meaningful, and be developed with input from experts. There's a distinction between an estimand and estimator that we should be thinking about. Issues like truncation by death are distinct from classical missing data problems. There's the importance of sensitivity analysis. I didn't really get into that, but I think a lot of us think that sensitivity analysis is important. And I think they had a lot of examples that do illustrate how naive approaches can lead you astray, can lead to bias. So I think they have a lot of nice examples that if you read through the document will be really useful if you're not used to thinking about these problems. And then what I think are some limitations, so this is just my own opinion, is I think I found, you know, the document a little challenging in the sense that they didn't use a lot of the established language from the causal literature, and the causal literature now is, you know, a good 30 years old with like a lot of now agreement, where there were a lot of disagreement early on. I think there's a lot of consensus here, so I was a little surprised by that. I think their examples of estimands are pretty narrow. Just even if you look at the whole range of them that were considered, they're sort of leaving out a lot of things that would make a lot of sense, and it seemed to be missing. There was little to no acknowledgement of G methods, and I think there's almost no controversy about G methods anymore. I think like the sort of link between estimands and identification is kind of largely a solved problem, and most of the debate now is about efficiency of estimators and robustness. So in my view, it was a little surprising to not see sort of this pretty established solutions not being talked about. And I think the biggest thing I would say is there wasn't much emphasis on the link between causal identification assumptions and the appropriate estimands, because I think these things are so critically linked. You know, if you, like for example, a principal stratification approach, it might rely on pretty weak assumptions if, for example, one treatment group doesn't have access to the other treatment. If they do, you have to make pretty strong assumptions. There's that estimand that they talked about, like, what if nobody had access to rescue medication? that would involve probably a pretty strong positivity kind of assumption. So I think it's not just which estimands do we want to know, but also, what is realistically identifiable from the data that we could collect. And I think we can't really divorce those issues too much. So, but overall, I think, there's a lot of, it's a really nice step forward, and there's a lot of useful information there, and a lot that I think we could agree to. So I'll stop there.
Thank you, Professor Roy. I was notified that live stream has been started in the ballroom in the 5th floor. So for those of you who might be standing or are uncomfortable in the floor, sitting on the floor, there is a live stream in the 5th floor. I don't know if you will be able to ask questions from that room. Okay, so it's my turn. I will be talking about causal estimands for randomized trials when we emulate a target trial. So what is an estimand? We're discussing estimands. What is an estimand? An estimand is a quantity that we would like to estimate using data. And what is a causal estimand? It's a causal quantity that we would like to estimate using data. So we can do causal inference with or without baseline randomization. When we have baseline randomization is when we run a randomized clinical trial, and this is typically a two-step process. First, we have to write the protocol of the randomized clinical trial that we want to run, and we can use the document that we are discussing here to inform the design of that study to define the estimand. And once we have that protocol, the second step is implementing the randomized clinical trial, recruiting patients, randomizing them, following them over time, collecting information on the outcomes, on the different characteristics of the patients at baseline, during the follow-up, how they change, etc. And once we have the follow-up complete and all the data in our database, then we have to implement the design and analysis that we specified in the first step. That's how randomized clinical trials work. When we cannot randomize patients, we usually resort to the use of real-world data, and that is causal inference without baseline randomization. And it's also a two-step process. In the first step, we specify our randomized clinical trial, the randomized clinical trial that we would have liked to implement if we had the resources. That is the target trial. And the second step consists on emulating the target trial that we specified in the first step. And to do that, the first thing we have to do is finding observational data that are fit for the purpose of our design. On occasions, we have to tweak the specification of our target trial to the nature of the data, because I'm sure you have experienced this. More often than not, we don't have all the information that we need in the data at hand. So we might need to tweak the target trial, but still keeping it scientifically relevant. And then once we have the data, we emulate the target trial, design an analysis according to the specification that we wrote in step 1. So that is target trial emulation, and I'm sure many of you are familiar with this approach. It's one of the main tools for causal inference using observational data, and it stems on the fact that we should be able to imagine a hypothetical randomized experiment to quantify every causal effect of interest, and that is the target trial. If we are not able to put our research question in terms of an ideal target trial, maybe we have to rethink that causal question. The main tool for target trial emulation is this table, and if you have read applications of this method, this table is pretty much in every paper. The table contains in each row all the components for the protocol of the target trial, and then we have 2 columns. In one column, we have to specify the target trial, what would be the trial that we would like to run, And then in the next column, we have to explain how we are going to emulate each of those components and explain whether we are doing some specific assumptions or we are getting to specific compromises to be able to emulate some of those components. So what is the causal estimand? The causal estimand is composed by these 6 components: the eligibility criteria, the treatment strategies, treatment assignment, outcomes, follow-up, and causal contrast. The junction of those components is the causal estimand. Then the last component, the statistical analysis, that's the set of tools that we will use to obtain a number for that causal estimand. That will be the estimator for the causal estimand. So let's review each of these components, and we will see that some of them are more relevant and will require more attention than others. The first component is are the eligibility criteria, and these are just the characteristics that define the population for whom we need to make policy or clinical decisions. The next component is the treatment strategies, and this is very important. A treatment strategy is a set of rules that dictates when and which treatment to assign during each time of the follow-up, including baseline. And these treatment strategies must be very well defined and exhaustive to be able to inform clinical and policy decisions. I wanted to say here that when we emulate a target trial using observational data, it's usually a pragmatic trial because there are some components that cannot be emulated. Blinding, placebo, or very tight monitoring, that's something that cannot be emulated. So we typically emulate pragmatic trials. Treatment strategies have to contain information of when to stop, when to continue, or when to switch treatments. Treatment strategies can be very simple if we are evaluating point interventions. For example, if we compare radiotherapy versus radical prostatectomy for localized prostate cancer, that is a single time intervention, so that's easy to specify. But a lot of us study drugs, and drugs are usually administered over a period of time, and those drugs can have toxicities, or those drugs can stop working at some point. So the strategies have to contemplate in which situations you should stop treatment and in which situations you should change to another treatment or just continue taking your treatment. Let me illustrate this with an example. This is an example of a post-authorization safety study. This is public. The protocol is published in the NCEP registry website. The results, the report is also there, and there is also a publication that explains the target trial emulation for this study. This was a post-authorization safety study that tried to estimate the risk of bone fractures in patients who received a specific drug for prostate cancer, radium-223. And this is how we define the strategies in this study. The strategy for those taking the drug of interest consisted of initiating the drug, but also we explained that they could stop the drug after 6 cycles, which was the indication, or even earlier if they had toxicity, if it stopped working because the tumor progressed, or if the patient didn't feel well enough to receive this drug, or if there was a worsening of the overall health status. We also specify that when they finished treatment with this drug, they could continue receiving the standard of care, because that is how treatment works for cancer patients. They go through different lines of treatment to treat the cancer. So we also reflected that in the treatment strategy. After they finished radium-223, they could continue with other drugs that were considered the standard of care. And we also specified that this drug, radium-223, could not be mixed with other cytotoxic therapy. So this is an example of a comprehensive treatment strategy that provides guidance about when to stop, continue, or switching treatments. We could have proposed other strategies, for example, receiving 6 cycles of the drug, and we would have been able to obtain a number for that. But that number would have been useless because in the real life, people don't receive 6 cycles. People receive 6 cycles if the drug works, if they don't have toxicity, etc. Okay, we'll go back to treatment strategies when we talk about per protocol effects. Other components of the causal estimands are treatment assignment, which in the target trial is at randomization. Outcomes is another component of the estimands, which are just those that are of interest for our research question. The follow-up that starts at randomization and ends at the occurrence of the event or death or loss to follow-up. And then the last component of the causal estimands are the causal contrasts. Here is where we explain which effect do we want to estimate. And we usually have 2 options. We can estimate the intention to treat effect, which, as Professor Roy mentioned before, is the effect of being assigned to one arm or the other. But this effect is very dependent on the pattern of adherence of the trial. We can have two randomized clinical trials studying the same treatment strategies with different intention to treat effects if they have different adherence patterns. Another causal contrast that I can study is the per protocol effect, which is the effect of following the treatment strategy that you have been assigned to. So let's go back to the example before, because adherence to a treatment strategy doesn't mean that you are taking the drug. It means that you are following the set of rules that are contained in that treatment strategy. So in our example, we said that patients that were assigned to the radium-223 arm could stop the drug if it was toxic, if it stopped working, if the health status worsened, or if they completed the 6 cycles. If they stop the drug and they are adherent to the treatment strategy, they are also allowed to initiate a subsequent treatment when they finish this drug, treatment with this drug, and those people are also adherent to the treatment strategies. In our example, who is not adherent to the treatment strategy? Those that combine the drug with another cytotoxic, because we were explicit about this, that was not part of the treatment strategy. So the point that I want to make here is that not adhering to a treatment plan is different from stopping treatment. You can stop treatment and be adherent to your treatment strategies. This is important because I need this information when I want to estimate my per protocol effect. When I implement the per protocol analysis, that's the estimator, used to estimate the per protocol effect, that's the estimand, I need to follow some rules that will be grounded on the specification of the treatment strategies. These rules are that data from the participants are censored from they deviate from the assigned treatment strategy, so I need to know all the details of the treatment strategy. As I mentioned before, if they stop treatment for clinical reasons, that's fine. They are being compliant. We also have to censor data from participants if we are not longer certain that they are receiving treatment. And then I need to adjust for baseline or post-baseline confounding that can be related to adherence. So to finish, what about competing events? As you know, in a failure time setting, a competing event is anything that happens after baseline that makes it impossible for the event of interest to occur. For example, if I'm studying cancer diagnosis and people in my study sample die because of cardiovascular death, I won't know if they have cancer or not. Competing events cannot be prevented by design, but neither using real-world data nor in a randomized clinical trial. And the presence of competing events can be a challenge for the interpretation of some effect estimates. Let me make an extreme example. Taking aspirin can lower the risk of cancer diagnosis by, for example, lowering the inflammation that promotes carcinogenesis, or by killing people. It can induce gastrointestinal bleeding, people die early, they don't have the opportunity to develop cancer. Those are 2 ways to prevent cancer with aspirin, and we are, of course, interested only on one of those ways. How can we accommodate competing events in our estimate? We need to we need to define our causal contrast, taking into account the potential presence of these competing events. So we need to specify the effect that will be estimated in the causal contrast when there are competing events. And we have different options here. One option is just redefining your outcome as a composite outcome. This is very common in oncology. You read randomized clinical trials of oncology. You've probably seen progression-free survival curves, disease-free survival curves, which just put together the death and tumor progression to estimate this outcome. We have other options. We can estimate the total effect, which would be the effect of treatment on the event of interest through all potential causal pathways. We can estimate the direct effect, which would be the effect of treatment on the event of interest that is not mediated by competing events. And there are also other frameworks that we can use to define the effects that we want to estimate. That belongs to the causal contrast, which is the last piece of the causal estimand when we specify a target trial. So, and this is my last slide, which summarizes what I explained, that target trial emulation is a two-step process. In the first step, I have to specify my target trial, and that specification is composed by the causal estimand, which contains these components that we just discussed: the eligibility criteria, treatment strategies, treatment assignment, outcome follow-up, causal contrast. And then in this specification, I also have to explain which tools I'm going to use to obtain the number for that estimand, which is going to be my estimator. That's the statistical analysis. Once I've been able to write that down, then I have all the resources I need to emulate that target trial. And of course, in the emulation, I will have to take care of some specifics, like emulating randomization by adjusting baseline confounding, and also taking good care of aligning time zero, the application of eligibility criteria and treatment assignment to avoid immortal time. Thank you.
Thank you. I have been asked to bridge what has been discussed about randomized trials and observational studies. So essentially, to answer the question, should we ask different questions in randomized trials and in the observational studies that emulate them? And it's a very simple answer. So it's now we should be estimating the same thing. And I could really finish here because really, we have a causal inference framework that allows us to unify language and methods across a study design, as Jason said. So if we have a causal question that is important enough to ask in a randomized trial, then we should also ask it in an observational study. And if the question is important enough to ask it in an observational study, we should ask it in a randomized trial. Otherwise, why are we asking the question in the first place? So the question is what causal question we want to ask. And if we want to look really sophisticated, rather than saying question, we say estimand. Right? We say the estimand framework, which is the question framework. We need to say which question we are interested in. So, okay, estimates, questions. And as we have said, the causal estimate is defined by the protocol of the randomized trial. So these are the basic elements of the protocol of a trial, as Xavi has shown, and the causal estimate is defined by all those elements. In the quotes estimand framework, the focus is on the last one, on the causal contrast. The causal contrast because all the other components of the estimand are fixed for a given trial. So if we have a given randomized trial, we have fixed the eligibility criteria, the treatment strategy. All these things are fixed by design. So the only thing that we can change is the causal contrast. And therefore, sometimes people talk about causal, when they talk about causal estimates, they mean just that part, the causal contrast, right? Because all the other things are already known. Now, the history of trials is that trials were only allowed to ask one causal question, which was this question, is what is the effect of assigning people to a treatment even if they don't take the treatment? That's the intention to treat effect. That has been for decades the only thing that we could legally do in a trial, estimate the effect of assignment to treatment. And many of us have argued for a long time that that was a waste, because we are putting a lot of resources in terms of money, in terms of labor, in terms of risk to patients into trials. And then we were getting just the effect of assigning people to a treatment, even if they didn't take the treatment. And that is what was done. So not only this was a waste, for some trials, it was malpractice. We cannot do this when the outcome is safety, right? We cannot do this for equivalence either. So that is the intention to treat effect. It was the effect of assignment to treatment, not the effect of treatment. And the intention to treat effect is not the only question of interest for patients, for doctors, for regulators. And we know it because we have asked them, actually. We have done focus groups with patients where we were asking them, we were explaining to them what their data was going to be used for. And when they understood what the intention to treat effect was, saying, no, that's not what I want you to use my data for. So the thing is that the intention to treat effect is a question that can be answered very easily. It's what we do with an intention to treat analysis. The intention to treat analysis is the estimator, and the intention to treat effect is the estimand. So if we do an intention to treat analysis and we don't have losses to follow up, then we can easily and without bias estimate the intention to treat effect. So we convinced ourselves for decades that that's what we wanted. There are many people still out there that tell you that what we really want to estimate is the intention to treat effect. That's what is of interest. It's not of interest for anyone. Sorry, it's not the only thing that is of interest, and is the only thing that we were estimating. So what is a causal question that is of interest for anyone who is conducting a trial is, well, what is the effect of assigning people to adherent to the treatment strategy that they were assigned to? And that's the per-protocol effect that Xavi has explained. For many years, we've been asking to please consider estimating per-protocol effect in trials, not only intention to treat effect. That's a very simplistic estimate that, for the reasons that we have heard today, and many others that are described in these papers, we shouldn't be using all these resources that go into a trial to estimate just the intention to treat effect. Let's also get the per-protocol effect. The problem with the per-protocol effect is that it is an observational analysis of a randomized trial. So any estimand other than the intention to treat effect is an observational analysis. And that's a problem. That is why trialists were so against doing anything other than an intention to treat analysis. It's because anything else relies on the same assumptions as observational studies. So if we want to estimate any other estimate, we are now transforming our trial into an observational study. And that was the problem. We had to make the same assumptions as in an observational study. You have to measure the confounders. We have to adjust for the confounders. All those things that trials are supposed to be great because we don't have to do, now we have to do them. And that's why the design and the analysis of trials for decades has relied on the intention to treat effect only. Not because it's what we want or the only thing that we want, it's because it's easy to do and we don't have to make any assumptions. And sometimes people did this naive per protocol analysis and published that, which is when we restrict our analysis to people who follow the protocol. That's an observational analysis of a trial, but it's a very bad observational analysis of a trial. Imagine that someone comes here to ISPE and present an observational analysis with no adjustment for confounding. You would say, what are you doing? Well, that is what the naive per protocol analysis of trials are. They are observational analysis of trials without any adjustment for confounding. They are not good estimators of the per protocol effect. So not something that we generally want to do. So this is the fight that many of us went into. Okay, let's do observational analysis of trials, but let's do it correctly, using everything that we have learned from observational studies. Because while this was happening, there was a lot of development in the causal inference literature for observational studies, and starting with Jamie Robbins' paper in 1986, we have a language and we have methods for causal inference for time-varying treatments. So we can make now causal questions very precise. We can define our estimands in a very precise way, and then we can articulate all these questions using observational data by specifying the protocol of a target trial. So, as Xavi said, when we make causal inference from observational data, for real-world data, we first have to articulate the causal question in terms of a target trial, and that defines our estimate. So finally, after all this time, we had a unified way of thinking about causal estimates in randomized trials and in observational studies. We could think of the effect of assignment to a treatment strategy or to a treatment policy. It's the same word. Different people use different words, and that's the intention to treat effect, or the effect of adherent to a treatment strategy, and that is the per protocol effect. And as I said, the methods to estimate per protocol effects are the same for randomized trials and for observational studies. If you know how to analyze an observational study and how to adjust for confounding, for time-varying confounding using G methods, then you know how to analyze a randomized trial to estimate the per protocol effect. It's exactly the same thing. Finally, we have no difference. And then the ICH E9 happened. So we were very excited because finally we were seeing how a lot of people were willing to move beyond the intention to treat effect in trials. So there were great expectations, and because there was a common causal framework now, this was a great step forward. And in fact, it was a great start. It was a very good thing to do. It opened the conversation. It put on the table things that people were not discussing with trials. Great, but. And when the public comment period opened for this, we actually wrote some things about saying what our views were on the framework. Not that they listened to us much, but that's a separate issue. But so this is great. It is fantastic that we are talking about this. As Jason said, some things that could have been done differently to get a better unification of trials and observational studies. And I really hope that there is room for improvement in future versions of the framework. And there are three things that I'm going to mention. We have only 15 minutes, so just three things that I think that we could still work on. One is the choice of words that is used, and these are also listed in order of importance. The choice of estimates, and we have to solve the lack of emphasis on treatment strategies, because the current version of the framework reinforces the idea that the goal of randomized trials is to compare treatments. But it's not to compare treatments, it's to compare treatment strategies. We cannot compare treatments, and as Xavi had explained. So, so let's talk about the terminology first. This is, in a sense, this is not very important. Different people have different tastes about how to name things, but there are some aspects of the terminology chose for this for the ICH E9 framework that it may lead to confusion. One is, for example, the intention to treat effect is now known as the treatment policy effect. Okay, you say fine, that's just a different name, but it's confusing because all estimates are about comparison of treatment strategies or treatment policies. So why is one of them known as the treatment policy and the others are not? That's weird. I mean, the pair protocol effect is the effect of adhering to a treatment policy. Why isn't that the treatment policy effect? Anyway, this is a very minor thing, but we have to keep in mind that an estimand, a contrast, a causal contrast, is a contrast of treatment policies. In all cases, it's not that one of them is a treatment policy. Then there is this term of intercurrent events. Oh my God, why did they have to come up with that? So this leads actually to some confusion, because some of these intercurrent events, like use of concomitant medication or treatment discontinuation, are really part of a treatment strategy. They're part of a treatment policy. It's not something separate. It's when we define the treatment strategy that we're interested in, as Xavi said, we have to describe when you start treatment, what are the reasons to discontinue treatment, all these things. If someone stops treatment because there is toxicity, we don't censor that person. That person cannot be censored. It's adherent to the treatment strategy. What else can the person do if there is toxicity, right? Keep taking treatment? No. So, and then the other component of the intercurrent event is death or other competing events. And there's a huge literature on this that is not really used in the framework. And they come with this new name. So a better connection to the causal inference literature will go a long way towards making the framework more helpful. And then, of course, just the use of the word estimand is a very technical word. I was very surprised that they were saying this is the estimand framework. We said, okay, you can call it the question framework or how we're going to define things. Estimand is a curious word, but it's even more curious that it's never referred to as causal estimand. Because estimand is whatever we want to estimate, but this is about causal inference. It's a causal estimand. When I ask people working on this, why are you calling it causal estimand? They say, because we think people won't like it if we say that. And being explicit about this is a causal estimand. That causal, the C word, still people were not using it. So I hope that changes. Okay, about the choice of estimands. Some of the estimands that are described here, some of the contrasts are not very helpful. For example, one is the while on treatment. While on treatment, if you put it in terms of a counterfactual contrast, is the effect of always treated versus never treated, which is not of interest because it's not of interest to patients, to doctors, or to regulators. Because who cares about what happens if we could somehow force everyone to be on treatment for the whole time, even if the treatment is toxic or it doesn't work, right? That's not a very relevant question. They also have the principal stratum estimand, which is the effect in a subset of the population that we cannot identify, but that would have certain characteristics. Well, as a patient, you tell me this is what will happen in a subset of the population that we cannot identify, and I tell you, am I part of that subset? We don't know because we cannot identify that subset. I'm not very interested in that, or as a doctor, or as a regulator. So some of these estimates are all put on the same level, but they're not very helpful. Also, they cannot be estimated, as Jason said, because the on-treatment one cannot be estimated, always treated versus never treated, because there is no positivity. Because that doesn't happen in the real world. The only way we can estimate it is if we make very strong assumptions. And the principal stratum, again, generally makes huge assumptions and cannot be used for time-varying treatments or not very easily. So then there is this composite estimand, which for rescue medication, again, is a conflation of the definition of strategy, what you do. And for death, it's just one possible way of dealing with competing events, not necessarily the best one. There are some others, and there's a lot of research in causal inference about this. So these estimates could be improved or emphasized more. But the main problem that I see, the main problem that is easy to fix and that I'm sure can be fixed in the future is this lack of emphasis on treatment strategies. If you read the training materials, it say from the ICH E9, it says the hypothetical estimand is the effect in a hypothetical scenario in which the intercurrent event would not happen. For example, when rescue medication must be made available for ethical reasons, a treatment effect of interest might concern the outcome if rescue medication had not been available. I don't think that's a great example of something that we are interested in if we live in a world in which rescue medication is always made available. But aren't we more interested in the effect in a hypothetical scenario in which people adhere to the strategies in the protocol? That seems to be like a natural example to say, if we want to know what would happen in a hypothetical scenario world, we want to know the hypothetical scenario in which the protocol is followed. Otherwise, why did we approve that protocol? The fact that that protocol was approved for the trial implies that those are the treatment strategies that we are interested in. Otherwise, we will have approved a different protocol. So if those are the treatment strategies that we are interested in, it seems like the natural causal estimate that we are interested in is what would happen if people have followed the protocol. So many of us argue that the most relevant causal contrasts are the intention to treat effect and the per protocol effect, which is, one type of hypothetical estimate. But bear in mind, all estimates are hypothetical. They are all. So the name is not also very fortunate there. So observational studies that emulate target trials try to estimate the observational analogs of both the intention to treat effect and the per protocol effect. So the key message that I want to finish with, because I think this is the main point of the main area of work to improve any framework about causal estimates, is that we do not compare treatments. We compare treatment strategies. Therefore, the causal contrast needs to specify the treatment strategies, including when we start treatment, what are the valid reasons for treatment discontinuation, and what we do, or for switching treatment, and what do we do about concomitant therapies. Plus, how do we incorporate competing events into our causal estimate? But see, all those things cannot really be done if we are talking about on-treatment estimate or principal stratum treatment. This is all about a strategy like what we have in the per protocol effect. So these are the strategies that we will have in the protocol of a trial or in the protocol of a target trial that we are trying to emulate using the observational data. And this is happening in causal inference from real world data now. It's happening. There are many examples. There are lots of papers. There are lots of people working on this issue. There is a common language. There are methods that are widely accepted. So it would be great if randomized trials could come into this same wagon, because all we are talking about here is about observational analysis of randomized trials. So thank you very much.
I want to thank you again to our speakers. Very great presentation, interesting, challenging, and there are some criticisms to the ICH framework. So before we open the floor to discussions using the microphone there, I'd like to ask Dr. Klutz and Dr. Morales if they have any comments or reactions to what has been discussed today.
So thank you for having me. I'm Paul Klutz. I'm a medical oncologist, not an epidemiologist. This is my first time at this fantastic meeting. I've learned quite a bit, and this was really interesting. I would just say that in the 12 years that I've been evaluating cancer clinical trials at the FDA, we almost always use ITT, and we almost always also get a per protocol kind of analysis as a supplementary analysis. and we almost never have one analysis. In fact, we never have one analysis. So I think there is a role for much of this in an individual trial. The idea that we're going to have one analysis is just not actually, doesn't happen in regulatory. I would say that I think the estimand, now I will also say I was not part of the ICH, so luckily I'm just a messenger. But I will say that I think it was a good start. As a clinician who goes through design discussions with statisticians, and when we're discussing things like observational studies with epidemiologists as well, having some systematic process to discuss the optimal design has been very helpful for FDA. So it obviously has work to be done, but I think it was a good start.
That's better. Yeah, no, I agree as well. I wasn't there at the guideline development, so I speak, I suppose, some of my views in that. I think, again, I think it was a good start. I think historically, there's been a very strong division between clinical trialists and observational research, and I think over time we are sort of breaking down some of those barriers and gaining additional value of real-world evidence for regulatory decision-making. And as we're doing that, I think there's more attention to the methods, the robustness of those methods, and there's greater evidence that there's the potential to use these methods. And I think I think we can go incrementally, and I just think we need to keep going in terms of keep demonstrating and the value of these methods with examples and evidence. And then when when further discussions come at guidelines, it's having all representatives around the table to have a good debate in these settings.
Yeah.
So I completely agree with both of you. This was a good start. The fact that we are talking about this now is fantastic for those of us who have been fighting for not using only intention to treat effect for decades. This is great. So no, there's no question about it. I just wanted to comment of this issue about using per protocol analysis in the past. Yes, it was a per protocol analysis, but it did not estimate the per protocol effect. So we call it per protocol analysis. It was a very naive analysis that did not estimate the per protocol effect. If you think about cancer trials, for example, you compare a chemotherapy A versus chemotherapy B, but at some point people taking the chemotherapy A switch to C, and people taking the chemotherapy B switch to D. And now what happened in a typical per protocol analysis is that when people switch from A, they stop taking A, so they censor them. They stop taking B, they censor them. But that's not what the per protocol effect is. In the per protocol effect, if you are taking chemotherapy A and it stops working or is toxic, and you switch to chemotherapy C, that's part of the strategy. That's part of a treatment. You don't censor people because they do what they have to do, the only thing that they can do in the real world. So the per protocol effect is not the effect of chemotherapy A versus chemotherapy B. The per protocol effect is the effect of chemotherapy A followed by chemotherapy C versus the effect versus chemotherapy B followed by chemotherapy D. That's the only thing that we can reasonably estimate from a trial or from an observational study, the effect of a treatment strategy that starts with A versus the one that starts with B. But we don't censor people when they stop taking treatment A or treatment B. So that was the confusion that existed for decades in the analysis of trials. People thought that per protocol analysis was estimating something useful. So now with the E9, with the ICH E9 new framework, we can start talking about these things, because even though many of us don't like the term intercurrent event, we think it's not necessary and potentially confusing, but on the other hand, it's putting on the table all these issues. So that's why I think it's a very good start.
Let me just respond to that briefly. While there is some controversy about the endpoint, progression-free survival is a commonly used endpoint that does take, and I've I think Miguel's had some questions about PFS in his papers as well. So PFS as an endpoint is a very common endpoint, and it helps
Sorry,
quite a bit.
I was talking about
OS. Yeah.
OS. Yes, OS. Yes.
The other issue is that if you wanted to go through a treatment policy type of situation, or you wanted to really define what's first, then second, then third, increasingly very, very hard to do in oncology. If you treat cancer patients, their selection of the next therapy is very preference-based, and it's very based on the toxicity of the drug, and it's also very the morbidities, the comorbidities of the patient. So we've even had a hard time requiring the control arm be a single therapy for that reason. There's so many options now that the patient and the clinician need to select based on their preference and based on toxicities, et cetera. And one of those preferences may be, I don't want to take any more therapy, and that's perfectly acceptable as an oncologist in later line cancers. But I completely agree with Miguel that if you're going to do a per protocol analysis, you should do it in a non-naive way, and that's something that I've learned from this conference, that there are some really important tools. Thank you.
Thank you. Yeah, if you can ask your question and address it to someone in the panel.
Yeah, Robert Gross from the University of Pennsylvania. First of all, thank you for an excellent session, very, very interesting and well done. I think there's an additional harmonization that's needed here, and that's with the adherence research world. So adherence is clearly the elephant in the room, where we've talked about, for many of the causal estimands, it's critical to have measured adherence and addressed it in the analysis. And yet we tend to measure adherence very poorly. So it's addressed, there are three phases of adherence from the adherence world. There's initiation, there's execution of taking the medications, and then there's persistence. And you've addressed persistence with discontinuation, relatively easy to measure. You've addressed with the modified intention to treat of initiation, but you haven't talked about measurement of execution. And I'm wondering if harmonizing between this group and the group that does adherence research, if there could be more advocacy for more precisely measuring execution of medication taking during a trial, so we can do a better job of getting at those causal estimands. Thanks. I'm looking for responses.
Can say something. I agree totally with you. One of the main problems is how we measure it, how we measure the adherence. In fact, in many trials are actually worse off than observational studies in that sense, because they measure adherence every 6 months, say, but we don't know when in the 6 months exactly happened. When in a trial, if you have good data on prescriptions and dispensation in an observational study, you may actually have better quality data on adherence. So this is a real problem. This goes to the other part that the estimand framework is trying to fix, which is that we are not talking only about the analysis of the randomized trial data, but about the design of the trials. So we design the trials in such a way that we collect the information that we need to estimate what we want, and that is key. In the example that we were discussing before about the chemotherapy, even if we have good data on adherence, even if we can agree of what is the treatment strategy of interest, going from A to C and from A to D, and say that, as you were saying, still different people are going to go to different chemotherapies based on their characteristics, based on their comorbidities, etc. Those are confounders now. So now, if we design a randomized trial in which we are serious about estimating the per protocol effect and we define the treatment strategies, not only we need good data on adherence, we need data on confounders, on time-varying confounders, because we are going to need those to estimate the per protocol effect. So if we take this causal estimand issue seriously, it completely changes how we design randomized trials, because now we need to collect data throughout the follow-up, not only on adherence, treatment, etc., but also on the determinants of adherence, on all these time-varying confounders.
And I would caution about using the term sort of use of concomitant medications or use of the next line. It's actually prescribing of the next line, but we don't know that it's actually used. Thanks.
Hi, my name is Sushama. I have a question. So if, like you said, if we are doing per protocol, if they change from treatment A to C, B to D, we still need to collect, we still need to consider them in the treatment line and B because of the strategies. how do we actually implement this in observational data? Because we don't know the reason they might switch. We might not have data for that. If they have toxicity, if they have allergy or anything, we might not get that data, or we might not have enough follow-up time, so we don't know why they're switching to another treatment strategy, and what, like, the reasons why we have the treatment strategy in the RCTs could be different from observational. The medication might be more expensive, might not be available, might not be covered by insurance or other details, right? So that's not in the treatment strategy. So how do we incorporate all these nuances in the observational studies to make sure that we are following the protocol strategies?
Just one thing, let's start with just knowing what the subsequent therapies were at all. And I think if we can do one thing, it's have no missing data, especially in oncology when you have an OS endpoint, on what were these subsequent therapies. It's not completely clear that you're going to get those all the time as people go in and out of healthcare systems, et cetera. So I think that's really, really important. And to your other point about why do people, not, especially patients with cancer, not adhere to a therapy? In a trial, it's not for cost, usually. Usually the drug's being given to them. In the real world, people do stop taking therapy for all sorts of reasons, logistical reasons, costly reasons, et cetera. So I think that's a point well taken, that the data that we would like may not be able to be received. And I think part of what was discussed with Dr. Califf and I think with Donna was this idea of improving source data. Like, it would be great if we could improve our source data and really get less missingness in some of the key variables like subsequent therapies.
And as a follow-up to that, of course, if we define if we carefully define a treatment strategy that says you are excused from continuing to use treatment when this biomarker happens or when you have toxicity or all those things, we need to have that information in the observational database. We need to have data on that biomarker or on toxicity. If we don't have it, then we cannot estimate the effect of that treatment strategy. So we can either quit or change our treatment strategy. And we could say things like, well, because this treatment is so important and everyone in our database has free access to the treatment, we make sure of that in our eligibility criteria, we will assume that if someone stops treatment, it's because they have toxicity or this biomarker level is found. So, and we can operate under that assumption. But it's always a matter of data, of course. If we don't have the data, that we need to decide who is following the strategy and who is not, we have a problem.
So if the strategies are too strict in the RCTs, it would be hard to technically emulate any target trials because we won't have all these information observational data.
Well, some we do, some we don't. If you keep it simple, like saying, hey, you have to start treatment the first time that your blood pressure goes about 120, and you have a database where blood pressure is measured every and also as part of your treatment strategy, you need to have a measurement of blood pressure every 6 months, right? So then you can probably use many electronic health records databases to do that. If you go very, you get very, like, okay, let's try to estimate the treatment as a treatment strategy in which people are have a measurement of blood pressure every week. And if it goes around 120 or more than 10% over the previous week, then you do this, and yes, you will hit a wall there. So we have to be realistic about what we can actually do with the data, which is what Savi was saying, that our specification of a target trial is an iterative process that in which we have to check that what we are proposing to estimate is something we can actually estimate with the data, a point that Jason also made.
Thank you.
Alec Walker, Boston. Please help me harmonize two perspectives. As a clinician, I want the best treatment strategy for my patient. As a regulator, I need to decide about a specific chemical entity, whether it should be approved or not. These seem to me naively to be leading to different estimands.
Yes, I agree.
And that's why there's often a distinction between what the requirements that regulators ask for, and then there's a difference for HTA, for example. There's increasing sort of work and collaboration to try to align some of those things. But rather than, I think it's really important and critical when data collections, because you need to do that in advance, and you need to think of all potential scenarios in that setting. Maybe with the observational data, you have more flexibility there, but I think with that more collaborative approach, trying to think of a variety of relevant estimands for different stakeholders in advance, and therefore the data lends itself to those analyses, even though different stakeholders may want to focus on a different analysis, would be a sensible way forward.
Thank you.
I will say that we focus very much on does it work, right? So we're why is there traditional, why is there frequent statistics? Why is everyone very focused on does it work? The first gateway is does it work? In oncology, thankfully, we have a very clear, tumor shrinkage situation where we are not approving placebos. In other therapeutic areas, it is very hard with time to event endpoints with some of the more challenging outcomes to clarify that. So there is a reason why we have been so focused on randomization and so focused on ITT at the regulatory level. I would also suggest that just because it's approved doesn't mean a patient's going to get it. And so we shouldn't just say, oh, well, the HTA could do something a little bit different, or maybe even sequencing trial by the National Cancer Institute. We can lower it down a little bit and see you're still moving patients, because I'm still treating patients too, away, or even removing access completely if the payer study doesn't go as planned. So I think we all need to be very, very, very careful about how is it working, the first question, and then we can talk about magnitude and supplementary analyses and things to figure out how well is it working.
I'm going to argue, I'm not so sure that a clinician and a regulator have a different interest here. I'm not completely sure. Or a patient, right? I mean, imagine we have a randomized trial for a new contraceptive method, and a patient if a couple goes to a doctor and says, hey, what about this new contraceptive method? And the doctor says, well, it didn't work much better than the others in this study, in which 30% of the couples did not use it as intended. Well, as a user of the contraceptive method, say, you are giving me the intention to do the effect. I'm not sure I want to know that, because I intend to use it as you tell me. So I want to know the per protocol effect. Same for the doctor. What's the per protocol effect in that case? And same for the regulator. I don't know why one would say, oh no, the intention to do the effect is much more important. You could say, oh, because in the real world, people will not take it as intended, so this gives you what will happen in the real world. Even if that's true, with the patterns of adherence may be very different in the real world and in the trial, it's not the information that I need to decide whether treatment should be used or whether I want to use it. So, not sure.
Thank you.
Yu Jiaxu from Taiwan, and I'm currently a PhD candidate in College of Pharmacy, University of Minnesota in the US. So thank you very much for the presentation. As someone is learning using target trial to my dissertation, this is really helpful. I have 2 questions. So the first is about the missing data. I've read that many articles about a review or actual application of target trial, but I noticed that one common thing is they really address how they handle missing data. So I wonder, is there, from your perspective, what's your opinions about the best practice about addressing missing data, such as all complete data analysis, missing indicator or imputation? And my second question about estimator. I know we talk a lot about estimand. I noticed that many target trial emulation, they use Cox regression model to estimate the hazard ratio. So if censoring is not a big issue for intention to treat, would you consider using other regression model, such as to estimate the risk instead of hazard ratio? Thank you.
So yeah, I think for the missing data one, I could take that as far as I think it, obviously I hate to give the answer, it depends, but it's really going to matter. Are you talking about an outcome or a confounder, and then you have to think about the assumptions. But if you're willing to make, let's say, missing at random type of assumptions, then I think there's a lot of existing tools that are perfectly appropriate. Various types of multiple imputation types of approaches. But if we're talking about the kind of competing event sort of situation where you don't see the outcome because somebody died, that's a very different situation where you wouldn't want to do imputation. But I think if we're talking about more just standard, occasionally there's a covariate missing. I think you want to think about why it's missing, but then you could use, I think, standard approaches there.
Is that part of the fitness of the data itself? At some point there's a missingness that maybe you shouldn't just use it.
I think it depends on the reasons, I think. But the nice thing about using multiple imputation types of approaches or something related is it builds in uncertainty about the imputation, so that if you have a lot of missing data, you're just going to get noisy estimates anyway, which, as you should. I'm not sure about the second part of the question, though.
Just to jump in about the missing data as well, often it depends on what setting we're considering it. So in an observational analysis, we commonly think of it at baseline and missing covariates. But from a trial setting, the aspect of missing data during follow-up and some of these censoring events, there are sort of recommendations of how maybe in trials they use multiple imputation at that stage. Now, I'm sure we could all have debate as to the relevance of and what might be the best methods or whether it's appropriate to do that for some of the follow-up things. But again, some of these guidelines will touch upon those as well.
Okay, thank you. I think we have time for one more question.
Hi, I'm Bora Plaku with Optum Epidemiology. I was wondering, have you ever or often encountered the pitfall where treatment strategies are too unique, leading to a positivity issue? And then what do you do in that case? Can you even still envision a causal contrast of interest?
Well, so yeah, it's a great question. I mean, one of the things that I've been doing in some of the work with my collaborators is we do come up with treatment strategies, and we do at least empirically start to look at, like, does it seem like there are people, at least some people are following these different strategies. So and then in some cases we find, oh, nobody's following something like this. We talk to the clinicians, we kind of learn why, and then we refine our treatment strategies that we're interested in, because we want our strategies to be realistic. And I think one of the nice things about thinking about treatment strategies instead of treatments is that it actually makes things more identifiable, like, because you can refine the strategies to be something that is actually happening in practice, where there is, some people are getting each strategy, there's some uncertainty about which one is best. Whereas if you stick to just treatments, you're going to have positivity violations. So I think you can continue to sort of refine your strategy to make sure that they are only realistic strategies that you're comparing. And I think you can partially do that empirically, but a lot also with discussions with the experts who are working with patients and making decisions.
Okay, thank you. So unfortunately, time is up. So if you want to stay and talk with our presenters, that would be great. I think this is a great discussion, and I hope it's the beginning of a discussion between the frameworks. And it's not only about language harmonization, but also about methods. So thank you.